Getting the desired products from any distillation system depends on being able to operate the system properly. Part of an operator's responsibility is to know how to start up and shut down the system. In a distillation system, a liquid mixture is separated into two or more components by partially vaporizing the mixture and then separately recovering the vapor and the remaining liquid. We can review the distillation process by examining the layout of the system used as an example in this program. The system is a continuous vacuum distillation system that separates a binary feed mixture, which is a mixture of two components. Here's a simplified flow diagram of the system. The mixture to be distilled is contained in this feed tank. In this system, the feed mixture is pumped from the tank to a preheater, where its temperature is raised close to the boiling point of the lighter component in the mixture. The mixture then flows into the distillation column, where vaporization occurs and the two components of the mixture separate. The heavier, higher boiling component collects at the bottom of the column as a liquid. Part of that liquid is circulated through a reboiler and back into the column. Circulating the liquid through the reboiler heats the liquid, which in turn provides heat to the column to help vaporize the mixture. Bottom's liquid that's been distilled enough to meet specifications is drawn off through a takeoff line. This liquid is known as the bottom's product. Meanwhile, the lighter, lower boiling component of the feed mixture rises to the top of the column as a vapor. It's routed to a condenser, where it's cooled and turned back into a liquid. The condensed liquid collects in a tank called a receiver. Part of the liquid, known as reflux, is pumped back to the top of the column. The liquid that's been distilled enough to meet specifications is called overhead product. It's pumped to an overhead product storage tank. Now, we said that this is a vacuum distillation system. Maintaining a vacuum in the column causes the feed mixture to boil at a lower temperature, which reduces the risk of decomposing the bottom's product. The vacuum for this system is created by a pair of steam jets. They draw air and other non-condensable gases from the condenser. The steam from the jets is condensed in these two condensers and collected in a condensate hot well, while the air and non-condensable gases leave the system through a vent line. Before a distillation system is started up, certain pre-startup checks should be made to ensure that the system is ready for operation. To illustrate typical pre-startup checks, we'll use a vacuum distillation system that separates a binary feed mixture. But these types of procedures can vary, so the ones we'll see should not be substituted for the specific procedures used in your plant. Here's the system we'll be using. It's being started up after a long shutdown period. To begin the pre-startup checks, a field operator closes a plug valve under the overhead product tank to prevent any loss of overhead product during startup. Then he selects a reboiler pump to circulate the bottom's product later on. This diagram only shows one pump. Most systems, however, have two pumps. Once the operator chooses the pump, he closes the drain valve and opens the suction and discharge valves for that pump. This procedure is known as lining up the valves. He also lines up the valves for the standby pump according to operating guidelines. He then starts the pump that he's chosen for a moment to make sure that it's operational. In the next step, the operator closes the steam trap drain for the reboiler to prevent steam from escaping later on. Then he opens an isolation valve in the reboiler steam line. A control valve in the line will be used later to admit steam to the reboiler. The next pre-startup checks involve selecting a reflux pump and then a feed pump, following the same basic procedures that were used with the reboiler pump. As before, this diagram only shows one of each pump. Most systems have two of each. An operator in the control room does this by checking a level indicator on the control board. To complete the feed system checks, the outside operator opens an isolation valve in the preheater steam line. A control valve will be used later to admit steam to the preheater. The next steps involve the vacuum system. First, the outside operator opens a valve to supply cooling water to the overhead vapor condenser, and one to supply cooling water to the vacuum system condensers. Then the inside operator checks the level in the hot well, which is a tank that receives condensate from the vacuum system. The hot well level is important because the liquid in the hot well acts as a seal to prevent air from being sucked back into the vacuum system. The two operators then complete the pre-startup by confirming that all of the necessary checks have been made. After the equipment in a distillation system has been readied for operation, the startup of the system can begin. To demonstrate typical cold startup procedures, we'll use a vacuum distillation system that separates a non-combustible binary feed mixture. Now, if a combustible mixture were being distilled, a precautionary step called purging would have to be performed before allowing the feed mixture to enter the column. Purging involves introducing steam, nitrogen, or carbon dioxide into a column to displace any oxygen that's present and reduce the risk of an explosion. Since no purging is necessary for this system, the operators begin the steps to move feed mixture into the column. First, a field operator starts the feed pump. At the same time, a control room operator sets a flow controller to open a valve in the feed line. This allows the mixture to enter the column. When the mixture in the column reaches a specified level, the operator closes the valve by moving the flow controller set point to 0. Since no mixture is flowing from the feed tank to the column, the feed pump needs to be turned off to prevent it from overheating. Next, before the mixture in the bottom of the column is heated, the vacuum system is started up. In this system, 2 steam jets are used to maintain the vacuum. The operator starts the jet that's farther from the column first by slowly opening a valve, which admits steam to the jet and gradually warms the vacuum system. Once pressure in the column drops, he opens the valve for the other steam jet in the same manner. When the vacuum in the column reaches the specified amount, preparations can be made to heat the mixture and begin the distillation process. In this system, the first thing that's done is to start the reboiler circulating pump. Starting the reboiler pump moves mixture from the bottom of the column, through the reboiler, and back into the column. Filling the reboiler with circulating mixture prevents it from being damaged when heat is applied. When the level in the column drops, the outside operator starts the feed pump. The feed control valve can then be opened as needed to feed the column. To ensure that the feed flowing to the column is heated properly, a control valve in the preheater steam line is gradually opened to bring the preheater up to operating temperature. At this point, heat can be applied to the mixture in the reboiler. To do this, a temperature controller is used to open a steam valve to the reboiler. As the reboiler warms up, it transfers heat to the circulating mixture. The heat added in the reboiler and the vacuum maintained in the column causes some of the mixture in the column to vaporize. The vapor from the top of the column is condensed in the overhead condenser. When the condensed vapor reaches a predetermined level in the receiver, the reflux pump is started, and a temperature controller is used to open a valve in the reflux line. All of the condensed overhead vapor then flows to the column as reflux. At this point in the startup, vapor is rising up the column and liquid is flowing down the column. For product separation to proceed efficiently, a specific range of pressures and temperatures must be maintained in the column. Column pressure is regulated by a controller that opens and closes a bleed valve in the vacuum line. Column temperatures are adjusted by regulating either the reflux rate, the boil-up rate, or both. The reflux rate is the rate at which reflux is pumped to the column. It's adjusted using a control valve in the reflux line.